Hello, everybody. Here we are, first lesson of Chapter 5, Polynomials. This is lesson 5.1 in Modeling Polynomials. So let's start with a definition of a polynomial expression. So polynomial expression is one or more terms whose variables have whole number exponents. Okay, so there's a few things I think we kind of need to unpack here. I would say the word terms. And also I want to mention briefly whole numbers. Integers are, our positive and negative counting numbers. -3, well, I don't want to talk too much about integers, but whole numbers are our positive counting numbers and 0. So 0, 1, 2, 3, etc., etc., etc. So not negative and not fractions. And terms is basically kind of like a unit, a chunk of math. Each of these individual parts right here, this is a term. This is a term. And this is a term. Okay, these are all term. This is a term. And this is a term. You can think about it as a chunk of math. It's kind of colloquial, but maybe that'll help you. And as we go, there's gonna be a few other words kind of important for us to remember. We have gone over them before, but let's go over it now. This would be coefficient. So a number it's being multiplied by a variable. Another one would be a variable. Another one, this one right here, remember, is our exponent. And this one right here that is not being multiplied by any variable is called a constant. It doesn't change. These ones can fluctuate, right, depending on what our value for x is. But this one is a constant. It's never going to change. And one other thing I want to point out, and hopefully we've gone over this a little bit, but the degree of our polynomial is our highest exponent. So here we have exponent of 2. Here you have an invisible 1. And here you could kind of think about having an x to the power of 0, which is just 1. But our highest exponent is 2. So the degree of this polynomial is 2. So let's say highest exponent value. Okay. So a few definitions, try to get those down in the space provided. And let's look at a few based on that definition that I just gave. So identify the polynomials in the following expression. So I would say, yes, this is a polynomial. It's got 1, 2 terms. Okay, so this is yes. Next, this one has a non-whole number exponent. So no, not a whole number exponent. This one is a yes. It has 1 term. This one would be called a monomial. And maybe I should say here, this one is a binomial. Has 2 terms. This one here is a no, and let me tell you why. We didn't really go over this that much with our exponents in our first chapter, but if you had x to the negative 2, it's the same as 1 over x to the 2. So this one has a essentially a negative exponent because it's not a whole number exponent, just like b. And this one is yes, we don't require a full number coefficient. So yes. And this one, again, is a monomial. Remember, mono means one, and it has one term. Okay, let's look at the next one, and I actually might make a little chart for this one. It asks us to name the coefficients, variable, degree, and constant term. So let's start over here. Let's go coefficient. Let's do variable. Let's do degree. And let's do constant. And I wish I knew how to draw straight lines. I'm sure there's some way to do this, but I'll do my best. And degree. And looks like there's going to have 4 columns. So this first one right here, negative 8y, our coefficient, so the number that is being multiplied by our variable is negative 8. Our variable, as you can see, the number that would change is a y. The degree, remember, is the highest exponent value. Remember, there's an invisible 1 right there. So we have a degree of 1. And a constant term we don't have. We just have one term, and it has a coefficient and a variable. So we don't have a constant term that is not going to change. Let's look at B right here. In this one, we don't have a coefficient. We don't have a variable. We do have a degree, I guess, of 0. So you can imagine like an invisible x here to the power of 0. And our constant term, this is only constant. It's never going to change. There's nothing being multiplied by anything. So that's all we have is a constant term. That's 12. This next one we'll be able to fill out the whole thing. So let's look. Our coefficients, we have more than one. So we have this negative 2 right here. But remember, there's an invisible 1 right there. So we have a negative 2, and we also have a negative 1. Next, the variable. There could be a combination of variables. There could be an x and a y or an a and a b. This one only has b, however. The degree, remember, is going to be our highest exponent. This is a 2. This would be a 1 there. So our degree is going to be 2. And our constant term, the thing that's never going to change, is this 10 right there. So these two could change. B, comes to represent that it could be a variety of numbers, but 10 is our constant. It's not being multiplied by anything, so it's not going to change. Let's look at our last one. So coefficient, again, remember there's an invisible 1 right there, so we actually have a negative 1. The variable is, again, b. Degree, remember, we do have an invisible 1 there as well, so it's 1. And our constant term, this one right there, let's not forget our negative in front of it. It's going to be a negative 4. Not going to change. Okay. Give you folks a second to get that down. Let's move on to our next question. Identify each polynomial as a monomial, binomial, or trinomial. So mono means 1. Think about monorail, monocle. Binomial means 2. Think about a bicycle. It's got 2 tires. And trinomial is 3. Think about a tricycle. It's got 3 tires, or your tricep, etc. So identify the number of terms. Okay, look, we just have just this one. That's a monomial. It's got one term. This one, we have a g. That's a term. We have this -4 times g squared. That's another term. And we have this +5. That's another term. So we have 3 terms, and therefore it's a trinomial. This next one, we have a -1. That's our constant. We have a plus xy. That's a variable. And finally, we have the plus y squared. And so that's another 3 terms. We have a trinomial again. And finally, we have a 4. And we have a -11 times w. That's 2 terms. So we have a binomial. Next, let's look at number 4. Identify the equivalent polynomials. And this might be a little bit easier, or I'll model some of them after with tiles. It's pretty easy to see, or easier to see maybe if you model them with tiles, or if you just like look and match the terms. So let's kind of do a little search. We're looking for one on the right that's going to have a -h². This one has a -h². Do any of the other ones? No. So it has to be these two that match. We can confirm, yes, they also have a -3, and they also have the +4h. So those two match. Let's look at our next one. We're looking for a 5m. This one does not have a 5m, but this one does, and also has the -3. So those two match. And process of elimination, this one's got to be it. But we can check, yes, it's got the -2, it's got the y squared, and it's got the +5y xy. And when I was talking about modeling them, I'll model these ones right here. I think we would have gone over this a little bit the day before, but remember our algebra tiles, a square like that, not colored in, is like an x². Colored in is a -x². One like this is just an x. Colored in is typically a -x. Sometimes you might see the reverse, that this is the negative, this is the positive. I find that to be confusing. And just a little square like that would be a 1, and a colored in square would be a -1. So if I model this one right here, say we would have 5 of these and -3, so 3 colored in. And if I were to draw this one right here, we would have our -3 colored in, and our 5 m's. So even though they're in a different order, you can see that they are equal. Okay, let's just do number 5 together, and then I think that's it. I'll give you your textbook questions after this. So write a polynomial to match the following conditions. So we want 2 terms. It's going to be a binomial, degree 1, with a constant term of 4. So we can do x. That's a term. It has an invisible 1 there. And we have a constant term of +4, so just +4. So is this 2 terms? Yes, yes. Does it have a degree of 1? Yes, we have that's our highest exponent. And does it have a constant term of 4? Yes. So ding, ding, winner, winner. Next, now we want 3 terms. Okay, degree 2. So let's go, 6x squared with a coefficient on the second degree term of -2. Sorry, I should have read further. So we want -2. We need 3 terms degree 2, the coefficient on the second degree term is -2. So this is our second degree term. Our